Hello friends. So now today we are on the last part of the inverse trigonometric chapter, that is part 4, in which we have to complete the miscellaneous exercise on inverse trigonometric chapter number 2. So first we are starting with the question number 1, cos inverse cos 13 pi by 6. Here the important point is this 13 pi by 6 is not in the range of 0 to pi. It means first we have to convert this one in the principal value branch. Similarly, in the question number 2, here it is 7 pi by 6, that is more than pi, is not in the range of minus pi by 2 to pi by 2. That's why first we have to convert it into the particular principal value branch. So this 13 pi by 6 we can write as 2 pi plus pi by 6. Correct? Similarly, in this question, this 7 pi by 6 we can write as pi plus pi by 6. Now, this we can write as simply cos inverse cos pi by 6. You know from your class 11th ASTC system. It is in the quadrant number 1. That's why answer cos pi by 6. And now you know cos inverse and cos, when they are in the particular principal value branch, these two neutralize, answer is pi by 6. Very simple. Similarly, in the question number 2, tan inverse, tan, you know, pi plus pi by 6 for 10, ASTC system class 11th, again pi by 6. So here we can write pi by 6. And tan inverse neutralize, so answer is again pi by 6. So important point, whenever the cos something degrees are not in the particular principal branch, we have to convert and then you have to write the final solution. Now, sometime you are not using the formula of tan inverse x plus tan inverse y. Sometimes question is only in terms of sin inverse x plus sin inverse y equal to sin inverse z. Or cos inverse x plus cos inverse y equal to something cos inverse. So how to calculate the questions like cos inverse plus cos inverse or sin inverse plus sin inverse. So we have two important forms. First we want to derive sin inverse x plus sin inverse y. What will be the formula for sin inverse? X root 1 minus y square plus y root 1 minus x square. This we want to prove. Suppose sin inverse x equals to alpha, same as what we have derived in tan inverse x plus tan inverse y. Similarly, sin inverse y equals to beta. Now, x equals to sin alpha, y equals to sin beta. If we apply the formula like class 11th for sin alpha plus beta, what we are getting? Sin alpha, cos beta, cos alpha, sin beta. Class 11th revision. So, alpha plus beta with sin is nothing but x cos beta. What is cos beta? Again 1 minus y square. Is it class 10th? How to convert sin beta y in terms of cos beta? Apply the class 10th identity. 1 minus y square. Cos alpha. Cos alpha is, here it is sin alpha. So 1 minus x square. And sin beta already with us. Y. So this is the value of alpha plus beta. We can convert to right hand side sin inverse. And answer is 1 minus y square plus y root 1 minus x square. Sometime we have to use this formula. For example, in question number 4, somebody want to prove sin inverse 8 by 17 plus sin inverse 3 by 5 and equals to, you have to prove tan inverse 77 by 36. Now I want to use only this sin inverse plus sin inverse formula. Then easily this one is our x, this one is our y. We'll have answer in terms of sin inverse, whatever be that. This sin inverse we can convert into tan inverse by our last article, how to convert sin inverse into tan inverse. So is another option. You can solve by converting initially in terms of tan inverse, then you'll get tan inverse. But somebody wants to solve, no, I want to solve only by using sin inverse plus sin inverse formula. Yes, you can. And similarly, we can derive one more formula for cos inverse. How to solve cos inverse, cos inverse? See, small change. If a formula of cos inverse x plus cos inverse y, then answer is cos inverse xy minus 1 minus x square and 1 minus y square. Why? The reason is very clear. Again from class 11th. Cos A, cos B minus sin A, sin B is a formula of cos A plus B. If it is minus, then you have to put here plus. Same as class 11th. So these two forms we can apply in some questions when you want cos inverse plus cos inverse or sin inverse plus sin inverse. Some more problems. Say sum number 5. Sum number 5 we can solve by converting in terms of tan inverse. Or you may directly apply the formula of cos inverse plus cos inverse. Sum number 5, same exercise. Cos inverse 4 by 5 plus cos inverse 12 by 13 equals to cos inverse 33 by 65. Now we see that cos inverse, cos inverse, cos inverse. It means we can apply our previous formula. So this one is our x and this one is our y. Now substitute cos inverse xy plus is here. So minus 1 minus 16 by 25 and 1 minus 144 by 169. Correct? X into y minus root 1 minus x square and root 1 minus y square. So here cos inverse 12/4 and 13/5 minus 25. 25 minus 16, 9. 169. 169 minus 25. Correct? Now cos inverse 48 by 65 minus this will be 3 by 5 into this will be 5 by 13. 5 and 5 cancel out. This is nothing but 3 by 13. And you know what will be the LCM for these two? Class 4th or 5th? 65 and 13. Sometimes student may write 35 into 16 LCM. No, it's a wrong concept. 35, 65 and 13. Don't write LCM as 65 into 13 because 13 5 is 65. So LCM is 65. We feel that it's a very small concept, but it is dangerous. So 65 and 13, 65, 48 minus 5, 3, 15. What we are getting? Cos inverse 8 minus 5, 3, 4 minus 1 and 65. This is nothing but RHS 33 by 65. Hence prove. So is another option. Now one more question. Say 8th sum. I'll give you only the hint, not the complete solution. Tan inverse 1 by 5, tan inverse 1 by 7, tan inverse 1 by 3 and tan inverse 1 by 8 equals to, you have to prove pi by 4. Now we see that we have 4 terms of tan inverse, tan inverse, tan inverse, but we know the formula of tan inverse x plus tan inverse y. No problem. We'll make pairs. 2 students sitting on one bench and 2 students sitting on another bench. So now you can easily solve this one. You can solve easily. Now again one portion and one portion. Again a formula of tan inverse and tan inverse. And again you apply you will get tan inverse pi by 4, that is only 1. And what is the value of tan inverse 1? Pi by 4. So in this manner, it's a good question. You can solve within 2-3 minutes. Now the next sum. Sum number 9. tan inverse root x equals to half cos inverse 1 minus x upon 1 plus x, where x belongs to 0 to 1. Starting from left hand side, suppose tan inverse root x equals to theta. It means root x equals to tan theta. It means x equals to tan square theta. Now the hint or the clue will be start from here. X is tan square theta, and some formula in class 11th, 1 minus tan square upon 1 plus tan square. Yes. So we have a formula of cos 2 theta, 1 minus tan square theta upon 1 plus tan square theta. So here we can write easily 1 minus x and 1 plus x. This is cos 2 theta. So what about 2 theta? 2 theta is cos inverse 1 minus x, 1 plus x. But we want only theta. So theta equals to half cos inverse 1 minus x, 1 plus x. And what is theta? What we assume theta? Tan inverse root x. Tan inverse root x, and is the solution from LHS to RHS. Good question. One more. These two are very important questions, 10th and 11th. Frequently may be asked in the CBSE exams. Sum number 10th and 11th. Though both are similar questions, equal weightage, 1 plus sin x, 1 minus sin x, 1 plus sin x, and 1 minus sin x. Very good question. X by 2 you have to prove, where the range is given 0 to pi by 4. Again, recall your class 11th concept of trigonometry. 1 plus sin x. We may write 1 plus sin x as cos x by 2 plus sin x by 2 whole square. Why? A plus b whole square is a square plus b square plus 2ab. What is a square plus b square in this case? 1. And what is 2 sin x by 2 cos x by 2? Sin x. Correct? Similarly, we can write here a small change. It will become a minus whole square formula. Nothing is new. Similarly, the denominator, fill in the blanks is for you. I am not writing this complete solution. So cot inverse. This will become, after opening the bracket, cos x by 2 plus sin x by 2 plus cos x by 2 minus sin x by 2. Yes or no? Divide by cos x by 2 plus sin x by 2 minus, open the bracket, cos x by 2 plus sin x by 2. Minus plus cancel out, and minus plus cancel out. We have cot inverse 2 cos x by 2 divided by 2 sin x by 2. 2 and 2 again cancel out. What is remaining? Cot inverse cot x by 2. Now, x by 2 is given in the range of 0 to pi by 4. It means, yes, it is in our cot inverse. 0 to pi is in the proper principal value range. Hence, cot inverse neutralize, and your answer is x by 2, that is RHS. Is a 4-mark question. This topic, inverse trigonometry, in the CBSE exam 2020-21 means coming year, weightage of the first chapter and the second chapter combined 8 marks. Relation and functions. and inverse trigonometric functions. These two combine 8 marks weightage. It means today we are completing about 4 marks weightage of CBSE exam. In last two chapters, third and fourth, that is matrices and determinant, we have already completed 10 marks. So today out of 80 of CBSE syllabus, 80 marks of CBSE syllabus, today we have completed 14 marks, more or less, out of 80, 14 marks completed. So now, answer is x by 2. One more question, a similar one, same importance of the question number 11th, equal weightage in the CBSE exams. Sum number 11, tan inverse root 1 plus x, root 1 minus x, root 1 plus x, root 1 minus x. You have to prove pi by 4 minus half cos inverse x, and limit is given minus 1 by root 2 to 1. Again the hint from class 11th trigonometry. You have a formula for 1 plus something and 1 minus something. 1 plus cos 2 theta and 1 minus cos 2 theta, direct formula. So here, if we put x equals to cos 2 theta, see what will be the change? 1 plus cos theta, but here 2 theta, 1 minus cos 2 theta, 1 plus cos 2 theta, and 1 minus cos 2 theta. Tan inverse as it is. What is 1 plus cos 2 theta? Tell me. Click. 1 plus cos 2 theta is 2 cos square theta. So it will become 2 cos square theta minus 2 sin square theta. Similar thing is here. You have to complete yourself. Tan inverse root 2 common cancel out. It will become cos theta minus sin theta, and it will become cos theta plus sin theta. Some steps you have to complete now. Cancel root 2, fill in the blanks for these two brackets, roots is. Now, this question already we have completed in the previous exercise. If you divide by cos theta, you will get tan inverse 1 minus tan theta and 1 plus tan theta. Again class 11th formula, tan inverse tan pi by 4 minus theta. And this range is given in the question 1 by root 2 to 1. It means it is in our proper principal value range, minus pi by 2 to pi by 2. So this will be nothing but pi by 4 minus theta. And what theta we assume in the earlier step? 2 theta is cos inverse x. So theta is half cos inverse x. Pi by 4 minus half cos inverse x. See, RHS. Very good question. The second option, the second alternate method for this one is, you can start initially inside the bracket, rationalize it. If you rationalize it, you will get the solution in the other manner. So both the methods are correct. You can solve by any one of the method. Okay. Next is 12th question. 9 pi by 8 minus 9 by 4 sin inverse 1 by 3 equals to 9 by 4 sin inverse 2 root 2 by 3. How we solve this? 9 by 4 and 9 by 8, and here it is 9 by 4. The hint is very clear that we have to take common 9 by 4. So starting from LHS, 9 by 4 is common, pi by 2 minus sin inverse 1 by 3. 9 by 4 is common and it is pi by 2 minus sin inverse 1 by 3. This pi by 2 I will write in the form of this one, sin inverse 1 by 3 plus cos inverse 1 by 3 minus sin inverse 1 by 3. Why? Yesterday's identity, last turn, part number 2 or part number 3 we have used. Sin inverse x plus cos inverse x is always pi by 2. That's why to manage this sin inverse 1 by 3, we are writing sin inverse 1 by 3 plus cos inverse 1 by 3 is our choice. Sin inverse 1 by 3 and sin inverse 1 by 3 cancel out. So it is only 9 by 4 cos inverse 1 by 3. But see, I want to write our result in sin inverse. So again, class 9th or 10th, 1 by 3, 1 is base, 3 is hypotenuse, 90 is here. How we convert cos inverse in terms of sin inverse? So 9 minus 1, 2 root 2. So here we can write 9 by 4 sin inverse perpendicular by hypotenuse equals to RHS. Good question. 9 by 4 is common, pi by 2. This is the turning point. For pi by 2, we are writing from our side these two just to cancel out sin inverse 1 by 3. Correct? Question number 13th. 2 tan inverse x. 2 tan inverse x cos x equals to tan inverse 2 cosec x. 2 tan inverse x. 2 tan inverse something. Direct formula we can convert in tan inverse 2x upon 1 minus x square. Listen, 2 tan inverse something. The formula is tan inverse 2a upon 1 minus a square. Here it is tan inverse 2 cosec x. It will become tan inverse 2 cos x upon sin square x. Comparing LHS to RHS. 2 cos by sin cot x, 1 by sin cosec x and 2 cosec x. This is cot and this is cosec. If you remember from your class 11th, trigonometric equations, how we solve the trigonometric equations. Cosec x is common, remaining is cot x minus 1. Or you can convert it into sin and cos. So here, either cosec x equals to 0 or cot x minus 1 equal to 0. Cosec x is 0, solve for sin x, convert into sin x because you know the formula of sin x equal to sin alpha. Cot x equal to 1 means tan x equal to 1. You know the formula of tan x equals to tan alpha. And in the last step, using class 11th trigonometric equations, you can write the generalized answer of these two. Somebody want to change here only in terms of sin and cos. He will. Then how we write? Then he has to write cot x means cos x by sin x into sin 1 by sin x. Cos x means 1 by sin x. You can solve by like this only. No problem. Because it is a question of class 11th. You can solve by different methods. Trigonometric equations. So just revise this chapter because 1 or 2 questions based on trigonometric equations. Next sum is one objective question. 16th sum. But don't make it as You feel na? The objective question है चलेगा, बहुत आसान होता है. We can substitute the 4 answers and check. Yes, is okay. If it is objective question, you can solve it. But if you want to solve as a descriptive, is a very good question. Question number 16. Sine inverse 1 minus x minus 2 sine inverse x equals to pi by 2. And we have 4 options given in your book. A is 0 half, B is 1 and half, C is 0 and D is half. Somebody wants to complete the question, then the alternate method is x minus 2 sine inverse x. Sine 1 minus x, we can shift 2 sine inverse x to right hand side. So this 1 minus x will be sine pi by 2 minus 2 sine inverse x. We can shift to the right hand side. Only 1 minus x is sine 90 minus theta, 90 plus theta, sorry. What is the value of sine 90 plus theta, class 10th? No? Okay. Cos 2 sine inverse x. Sine 90 plus theta is cos theta. This is 2 sine inverse x. If we suppose sine inverse x is theta, then it will become cos 2 theta. And cos 2 theta, if you want to convert, again class 11th, in terms of sine, you know the formula, 1 minus 2 sine square theta. This is 1 minus x. 1 minus 2, what is sine square theta? Theta is sine inverse x. So x is sine theta. So here we can write x square. 1 and 1 cancel out. Minus minus cancel out. So here x common. 1 minus 2x equal to 0. X equals to 0 or x equals to half. Now when you substitute and check for x equals to half and x equal to 0, you will find out that x equals to half is invalid. Will not satisfy the given equation. Hence answer is x equals to 0. Very good question. Is given only in the objective, but I feel that is a good question of subjective type. Okay, now the chapter or the miscellaneous exercise of the inverse trigonometry completed. My favorite questions for your homework. करेंगे ना? Okay. So 2-3 questions. My favorite questions you have to complete, not from the NCERT book. First question. Homework. If cos inverse x by a plus cos inverse y by b equals to alpha, then prove that x square by a square minus 2xy by ab cos alpha plus y square by b square equals to sin square alpha. Is my favorite question. Yes. Second sum, show that sin cos inverse cos tan inverse x equals to root x square plus 1 x square plus 2, and the last one, three sin inverse 2x upon 1 plus x square minus 4 cos inverse 1 minus x square upon 1 plus x square plus 2 tan inverse 2x upon equals to pi by 3. These 3 questions for your homework. Okay, करेंगे ना? कैसी चल रही है पढ़ाई? I think you are working very hard. We have completed 3 topics: matrices, determinant, and now inverse trigonometry. Lectures पसंद आ रहे हैं? अच्छा लग रहा है? तो गुरु दक्षिणा में कम से कम एक लाइक तो मिलेगा. गुड.